Ever wondered how a small force could lift a huge load? This phenomena has to do with Pascal's law or hydraulic system. But how can one transfer power so efficiently using only fluids? Let's find out. The center of gravity refers to the point at which an object's weight is distributed evenly in all directions.
Planck's demonstration and visual that help illustrate the concept. Hydraulic system operates in Pascal law, which states the pressure applied to a fluid in a confined space is distributed evenly in all directions. In a hydraulic lift, when force is applied to a smaller piston, it generates pressure in the fluid, which is transferred to a larger piston. Since the larger piston has a bigger surface area, it creates the greater lifting force, allowing heavy objects like cars to be raised. A simple diagram would show the smaller piston pushing fluid into the larger piston, lifting the car, which illustrates how the system uses fluid pressure to remove heavy loads with less effort.
In a hydraulic lift, such as those used in car repair shops, the lift raises heavy vehicles by distributing pressure through a fluid following Pascal's law. As the lift raises the vehicle, the system must account for the vehicle's center of gravity to maintain balance. If the car's weight is unevenly distributed, the center of gravity shifts towards the heavier end. This shift means the hydraulic system must be precisely aligned with the car's center of gravity to prevent tilting or instability during lifting. To visualize, consider a car balanced on a lift. If the center of gravity is directly above the lift's center support point, the system remains stable. However, if the center of gravity shifts too far to one side, the car could tip, stressing the hydraulic system unevenly.
Hydraulic cranes utilize a system of hydraulic pumps, cylinders, and valves to generate and control fluid pressure. This pressure applied to pistons within the cylinders create a mechanical force to lift heavy loads. The crane's boom, counterweight, and out-triggers enhance its lifting capacity and stability.
Hydraulic cranes rely on the power of hydraulic pressure. When pressure is applied to a fluid in a confined space, it transmits that force equally throughout the fluid. This principle, known as Pascal's law, allows hydraulic cranes to lift heavy objects with precision. By controlling the flow of hydraulic fluid, the crane can maneuver heavy loads with ease.
Imagine squeezing a tube of toothpaste. The pressure applied spreads evenly, pushing the paste out. A hydraulic system works similarly but with fluid. According to Pascal's law, pressure applied to a confined fluid transmits equally in all directions. This allows a small force on a small area to generate a larger force over a larger area, like a seesaw balancing act. This principle powers car brakes, construction machines, and amusement park rides.
Pascal's law is useful in our daily life because it provides for the effective transfer of force using fluids, which makes numerous tools and machinery function properly. As an example, in hydraulic systems such as automobile brakes, lifts, and construction machines, small forces applied to a fluid may produce far greater forces used for lifting heavy objects or performing various tasks. These lifts improve efficiency, safety, and convenience, making them helpful in both everyday tasks and industrial settings.
Practical examples for hydraulic cranes is crucial. First is on construction sites. It provides versatile lifting of concretes. Second is on transportations. It performs quick and stable shipping of heavy loads. Third is in mining. It assists heavy components in an open pit mines.
By knowing the center of gravity of a hydraulic lift, it ensures the safety of whatever item will be lifted off the ground. By being stable and balanced, the risk of the lift's platform tipping or falling is lessened, therefore minimizing the possibility of damages. It is important that the structure of the lift itself, its base, is stable, centered, and can take the weight of what will be lifted.